Number 6 is using a special function of sine formula that say that limit of sine t over t when t approaching to 0 is equal to 1. And the number 7a also is a conclusion of number 6 and say sine x equivalent to x when x approaching to 0, or even sine exponent to n x also equivalent to x and when x approaching to 0. And number b also is the conclusion of a and 6 also, because by using the formula of cosine in terms of sine we can reach to that we use cosine x equivalent to 1 minus x2 over 2 when x approaching to 0, and also for cosine power n we can say that is equivalent to 1 minus n x2 over 2 just when x approaching to 0. And also for tangent x also we can say that whenever x approaching to 0 we can use tangent x equivalent to e, and also tangent x also we can say that it equivalent to 1 over x. Let's go to example and see how we can use formula overcome with indetermination forms. For example, here we have the limit of cosine 6x minus 1 over x2 when x approaching to 0. If I use the distribution here, cosine is 0 is 1, 1 minus 1 is 0 over 0. You have to get rid of it, this indetermination form. I can see the sign here, but I can convert and rewrite this in terms of sine. Go back to the formula for cosine in terms of sine. We have cosine 2 is equivalent to cosine 2x minus sine 2x, which again I can write here in terms of sine. So cosine 2 also is 1 minus sine 2x. Here I have minus 2x. So together I have this formula is equivalent to 1 minus 2 sine 2x. So here I can write cosine in terms of sine. Let's here we put cosine 6x. So here is suppose that we have u, and I can write 6x in terms of 2 times 3x. So here the x replaced by 3x. So here I can write 3. So I have 1 minus 2 sine 2. Instead of x, I will write here 3 minus 1. So 1 minus, so this limit sine 2 over when here x to 0. When it's approaching to so according to here 1 and 1 power can come I have minus 2 sine 2 limit, then I can I can write here minus, so the limit is coming here because it's continuous function that limit of sine u over u is equal to 1 when u approaching to 0. So just if I had here 3, then I can use the number 6. So I will write here 2 limit of sine 3x over x2. So I need 3 here. I can multiply here 3. So I will bring here 1 over 3. Sorry, here 3 because I time by 3. So here I can use and write as the limit of this one when x approaching to 0 is equal to 1. So here I can write minus 2 times 3 power 2 is 9. So I have minus 18. So this one, it was a strategy of number 6. So let I write here number 6 and 7. The strategy of using limit of sine u when u approaching to 0 is equal to 1. Even I could use directly from 7, and I could write instead of cosine x 1 minus x2 over 2. Here another example, limit of cotangent x minus 1 over x minus 1 when x approaching to 1. To solve this problem, if I substitute 1, so I will get the tangent of 0, that is cotangent of 0, which I here the cotangent line. So the cotangent line is this. In 0, a cotangent line is with the distance and equal to infinity. Here I have infinity over 0. That is another type of determination form. So to get rid of, I need to use directly this formula, which I could instead cotangent is equivalent to 1 over x, because I can write cotangent in terms of tangent, and so it's coming to 1 over tangent, that is equivalent to 1 over x. But here, suppose that I don't remember this formula, and just based on the number 6 I want to solve, and I just know that the limit of sine t over t when t approaching to 0 is equal to 1. So let's write this in terms of that. And so here I can write actually cotangent cosine of minus 1 over sine x minus 1 over x2 minus 1. I can write as x minus 1 times x plus 1. So here we can rewrite as the limit cosine x minus 1 x plus 1 is coming here, x plus 1 over sine x minus 1 here over x minus 1 when approaching to 1. And here pay attention that we won't use the limit of sine x minus 1 over x minus 1 is equal to 1. So because when x approaching to 1, I can say that x minus 1 approaching to 0. So if I define this as u, I will use that limit of sine u over u when u going to 0, so is equal to 1. So u is x minus 1. So sine u over u is equal to 1. X approaching to 1, so x plus 1 is equal to 2. But the cosine of x minus 1 is cosine of 0. But here we have to pay attention. Cosine of x minus 1 is located in which quadrant? Limit of cosine if u when we are approaching to 0. If u approach from 0 from right side, it means that we are in the first quadrant, and if u approach to 0 from left side, it means that we are in the fourth quadrant, and for the cosine both are positive. And so here we can write 1, and here will be 1 multiply 2 over 1, which is equal to 2. Thank you for your attention. We are in the end of this section, and we continue for the next section. If you are interested, you can follow